Okay, continuing where we left off, we're going to look at some applications now. Okay, so first is speed, distance, time. Now these three formulae are no longer on the reference sheet, so you need to memorize them. And I think the easiest way to do it is to remember speed is distance over time. And then once you remember speed is distance over time, you can draw this triangle out, and that helps you remember the other two. So, or you can simply just rearrange to get the other two. So speed is distance over time. So speed's like the bottom left there. Distance is at the top, and time's like the bottom right. Okay, so that's how you can get from there to this triangle. And then using the triangle, you just cover what you want to find. So if you want to find distance, cover speed times time. Okay, etc. If you want to find time, cover time, it'll be distance over speed. All right. So these three formulae not on the reference sheet, but you're expected to memorize. The other thing to be aware of with speed, distance, time is to be very careful with the units that the different questions are in. You might need to have to convert between the units. Okay. All right. Here's a question. So car takes 6 hours to complete a journey when traveling at 60 kilometers an hour. How long? Same journey if traveling at 100 kilometers an hour. So first thing is I'll work out the first sentence. What do I have? I've got a time of 6 hours. I've got a speed, and you can tell it's a speed because of the slash. Speed is of 60 kilometers an hour. So what can I work out? If I know the time and I know the speed, I can work out the distance. So distance is speed times time. Okay, so it's 60 times 6, which is 360. The units for distance, because the speed is kilometers per hour, the units will be kilometers for distance. So I know that the distance is 360 kilometers. How long? So it's asking me how long in terms of time would the same journey take if the car was traveling at 100 kilometers an hour. So if the speed changed to 100 kilometers an hour, how long would it take to do a distance of 360 kilometers? So now I need to work out time. Okay, time is distance over speed. So 360 over 100. So time is 3.6 hours. You know it's hours because you can look at the unit. Everything in the question is in terms of hours. So we have a look. A lot of people might be tempted to write C, but that's not correct because 3 hours and 6 minutes is not the same as 3.6 hours. Okay. Okay, think of it like this. 0.5 of an hour is like half an hour. So it's going to be more than half an hour. So it's going to be more than 30 minutes. So look, it's going to be D. If you want to know how to get exact, use your calculator DMS button. That'll change it to 3 hours and 36 minutes. Okay, so it's D. Okay. Next one, another common application they ask in terms of speed, distance, time is your stopping distance, which is made up of two components, the reaction time distance and the braking distance. So reaction time distance is basically how far the car travels before you've got your foot on the brake. It's dependent on how fast you react. And the braking distance is how far you travel while your foot is on the brake. To find the reaction time distance, use distance to speed times time. Often, though, you need to convert units. This is a handy thing to remember. Kilometers per hour to meters per second, you divide by 3.6. If you can't memorize it, that's okay. You can just focus on the units and convert units, and you'll be able to convert. It takes a little bit longer if you don't remember this divide by 3.6, but you can still do it. Okay. Braking distance, you'll either be given in the question or you'll have a formula that you'll substitute in and easily be able to achieve it. Just be very careful with units. Okay. So here we go. We're driving at a speed of 100 kilometers an hour. Brake suddenly. It takes 2 seconds to react. And there's a braking distance of 59.2. So we know the braking distance is 59.2 meters. Okay, we need to work out the reaction time distance. Okay, so to work out the reaction time distance, it's a distance, so it's going to be speed times time. And the important thing is that the units have to all match up. See, the braking distance is in meters. We want to know the stopping distance, most likely in meters. Keep everything in meters. So this kilometers an hour needs to change to meters per second. So you can either remember divide by 3.6. Okay, and if you divide 110 by 3.6, you'll get 30.5 repeater. Can either remember that, or I don't remember. I find it hard to remember that particular number. or if you find it hard to remember the number, change 1 unit at a time. So kilometers, we want to change it to meters. So there are 1,000 meters in a kilometer. So that'll be that per 1 hour. And then we change the 1 hour. Now 1 hour is 60 minutes, and in 60 minutes there are 60 seconds. Okay, so you'd plug this bit into your calculator, and when you do this, you get 30.5 repeater meters per second. Okay, so I change 1 unit at a time. The first unit in the numerator, the second unit per 1 of the second unit. So it would be 1 of the second unit in the denominator, and then you just change the kilometers to meters, and then hours to seconds, and then plug it into your calculator. Okay, so either way, we get that the speed is going to be 30.5 repeater meters per second for 2 seconds. So doing that, we get 61.1 repeater. So the stopping distance is going to be the addition of the reaction time distance and the braking distance. Now the braking distance we already know is 59.2. So it's going to be 61.1 repeater plus 59.2. Sorry, not repeater, just 59.2. And that is 120.3. And I'm just going to put it to 1 dp here. It doesn't say what to round it to. I'll do it to 1 dp. Okay. Another application you need to be aware of, it's in the syllabus, is blood alcohol content. So you're back. So basically, just be aware of what units it's in. It's how many grams per 100 mils of blood. Okay, so how many grams of alcohol per 100 mils of blood. So that's what it is. Okay, it's usually a very, very, very small number. Okay. Any formula required to calculate the blood alcohol will be given to you on the exam paper. So nothing to memorize here. Okay. You are supposed to be aware of the limitations of the formula. Okay. It's only got a few variables in it: the number of standard drinks, hours you've been drinking for, and your mass. However, there are other variables that can depend on, for example, your fitness or your liver function. Okay. So just be aware of limitations in the formula. All right. All right, let's do a question here. We drink 2 small bottles of wine, 3-hour period. So straight away, 3-hour period tells us the time. So the number of hours drinking is 3 hours. Okay. Each of the bottles is 2.3 standard drinks. So it's really important that a lot of people would go, oh, 2.3 standard drinks, but that's each bottle. There are 2 bottles, so you need to times that by 2. It's 4.6 standard drinks, so be aware they'll try and trick you there because you'll drink multiple of something, so you've got to multiply the number of standard drinks. And the weight is 53 kilograms. Okay, so now we've got each of these variables, we can work out the blood alcohol at the end of the period. So we're just substituting into the formula now, times by the H, which is 3 over 5.5 times the M, which is 53. And then you just put that into your calculator, okay? And I got A to 3dp. All right, next one. Notice there's a different formula for female and for male. The only thing that's different is the number and the denominator. Maximum number, so 84 kilograms. So straight away, 84 kilograms. 4 hours, so 4. And we want to maintain a blood alcohol of less than 0.05. So we're being told the blood alcohol concentration has to be less than 0.05. But if I want to know the maximum drinks I can do, I'm gonna make it 0.05. Okay. So substitute in. So the blood alcohol 0.05 equals 10. Now we don't know the number of standard drinks. That's what we want to find. We want to find the maximum number of standard drinks. So we want to find N. So minus 7.5 times the H, which is 4, over 6.8 times the M, which is 84. What I like to do now is just quickly get my calculator and work out these 2 bits. That's what I like to do. So I did that. So that's going to be 30, and the bottom was 571.2. Okay. And now we need to work out n. So we need to rearrange this equation for n, times both sides by the 571.2. Okay, so 10n minus 30, that'll remove the fraction, equals 0.05 times 571.2. Okay, we get 28.56. Add 30 to both sides. You get 58.56 and divide by 10, which is 5.856 standard drinks. And that's your answer. The last type of application they mentioned in the syllabus is medication doses. Any formulas that are required will be given to you in the exam paper. They mentioned 3 specific formulas in the syllabus. Each one of those, they will give you that formula. The key thing to be careful of is the units in the questions. Just read the question carefully, make sure your units are okay. So here's Young's formula, that's one of the 3 that they mentioned. It's for children ages 1 to 12. Okay. So let's substitute in. Child's dose is 20 milligrams, so dosage for children, that'll be 20. Based on adult dose of 40. Okay, so the adult dose is 40 milligrams. How old is the child? So the age of the child in years, that's what we want to work out. So just substitute in so D is 20, Y times by the adult dosage, which is 40. Over y plus 12. Okay. All right. I've got one fraction here. I'm going to multiply both sides by y plus 12 because there's 2 things in the denominator. I'll put brackets. I'm going to multiply, so it'll be 20 bracket y plus 12 is equal to, and that's just 40y on the numerator. Okay. Expanding the bracket. We always expand brackets. Make sure you times both by 20. You can either minus 40 from y's from both sides or 20 y's. I'm going to minus 20 y's from both sides. So it's going to be 240 is equal to 20y. And then divide both sides by 20. And you get 12. Now the unit, it's in years, and this is in years. It's good. So it's going to be 12 years. Okay, good. D. Next one. We've got Fried's formula. It's a different formula. Children age 1 to 2 years. Now notice that this one has age in months. Some of them have age in months, some of them age in years. As soon as I see 1.5 years, but I see that the age is in months, I'm going to times by 12. So it's going to be 18 months. Straight away, that age is going to be 18. So the child dosage is 450. Make sure you know if you're looking at the child dosage or the adult. This is for the child, the 1.5-year-old. What is the adult dosage? So let's substitute in. So 450 equals to 18 times adult over 150 times both sides of the equation by 150. So we get 450 times 150. And I'm going to go straight to dividing by 18. So whatever that number was, divide by 18. And we get an answer for the adult dosage, which is right underneath 3,750 milligrams. Notice the same. It's always for these questions, medical questions. Whatever unit for the child, the same unit for the adult. Okay. All right. I'll see you in the next video.